The shadow of a pole 5 square root of 3 meters high is 5 meters. Find the angle of elevation of the sun. The shadow of a pole is 5 square root of 3 meters high, of a pole that is 5 square root of 3 meters high. So this is the length of the shadow of the pole. We've been told that the length of the shadow of the pole is 5 meters. Now how do we find the angle of elevation of the sun? So let's give a pictorial representation of the question. So let's assume the pole. Let's sketch the pole. So let me pick this point here, and let's say we have something like this to be our pole of this length. Let me pick this point. So let's just assume that this is our pole here. You could call it anything you like. So this is our pole. Yeah. Now this is the pole. Now then let's say you have the sun. Maybe the sun is somewhere here that shines its light. Now when the sun shines its light, it's going to exhibit a ray, and then the implementation of the exhibition of the ray is going to cause the shadow of the pole to be reflected on the ground surface. So let's say this is the shadow of this. Let me just sketch the ground. Let's say this is the plain ground, something like this. Something like this. Let's assume this is the plain ground. So what we have as the shadow of this pole is going to be something. Let's just say something like this, something of this nature. So this is the shadow of the pole that we have here. Now according to the question, we've been told that the pole is of length 5 square root of 3 meters. That is from here to here down to here is 5 square root of 3 meters. And then we've also been told that the shadow of the pole is 5 meters high. Sorry, is 5 meters. So that is from here to here to this place here is 5 meters. So now from this point, let me join this point to the point we have here. So this is what we have. We have something like this. Now we've been told to find the angle of elevation of the sun. So definitely from the top of the pole to this point here. So the angle of elevation from this shadow to, you can see, so anybody that stands at this point, to view this part, to view this the top of the pole, you need to raise your angle of horizon. So this is going to be your angle of elevation. So we're going to call this angle theta. So we've been told to find angle theta actually. Now to find angle theta with respect to this angle here, the side facing angle theta is called the opposite. Now this is 90 degrees. So the side facing here, the side facing angle 90 degrees is called the hypotenuse, while the last side of a triangle is called the adjacent. So this is called the adjacent. But looking at the question we have been given, we've been provided with the opposite and the adjacent, and we're told to find theta. So now, which of the trigonometric functions do you use? Do you use sine, do you use cosine, or do you use tangent to find theta? Well, to do that, or to answer that question, we're going to lay credence to an acronym. I'm not sure if you can remember, but it says SOHCAHTOA. Now what sine means is opposite all over hypotenuse, the cosine means adjacent all over the hypotenuse, and then the tangent means, sorry, the formula for the tangent is opposite all over the adjacent. Now looking at the triangle, we're only given opposites and we're given adjacent. So since we're given opposite and adjacent, it implies that we're going to use tangent, because it's only tangent that has the opposite and the adjacent attached to it, while others do not have that. So since we have that, so let's just write that straight up. So we have that the tangent of theta equals the opposite, which is 5 square root of 3, divided by the adjacent. So let me just write the formula down. We have the tangent of theta equals the opposite all over the adjacent. So the tangent is this, and the adjacent is 5 meters. So when we divide 5 by 5, you have your tangent of theta equals square root of 3. So how do you find theta? Now to find theta, we're going to lay credence to our reference triangle. Now the reference triangle is, let's say this is your triangle. This is our reference triangle that we use in determining angles of problems of this nature. So this is 30 degrees, while this is 60 degrees, and this is 90 degrees. So here is 1, here is 2, and then here is the square root of 3. So what the question says is, the tangent of what angle is going to give me the square root of 3? The tangent of what angle will give me the square root of 3? Now looking at what you have here, if we consider, when you consider angle 30 degrees, so the tangent of 30 degrees, that is the tangent of 30 degrees, that's going to be the opposite. So this is the opposite, that is 1 all over the adjacent. So this is the adjacent, because we know the side facing angle 90 degrees is always the hypotenuse. So this is the adjacent, which is 1 all over the square root of 3. So apparently this is not equal to 3. So that implies that theta cannot be 30 degrees. Theta cannot be 30 degrees. So but we have another angle here. So with respect to this angle, which is 60 degrees, so the tangent of 60 degrees equals what? Now with respect to this angle, with respect to 60 degrees, the opposite is the square root of 3. So we know this is the hypotenuse, while the last side is going to be the adjacent. That is going to be divided by 1. And the square root of 3 divided by 1 is the square root of 3. So that implies that of these two angles, it is only 60 degrees that has its tangent to be the square root of 3. So we've been told to find the tangent of what angle gives us root 3, and we have just shown it here that theta has to be 60 degrees. Well, you can confirm this with your calculator, but that's the way to find it, because most times problems of this nature you would not be allowed to use your calculator. So because of that, you should know how to make reference to the reference triangle when solving problems of this nature. Anyway, our solution is 60 degrees, so that completes the problem. If you have any questions in this area, please feel free to drop your questions in the comment box below. Thanks for watching.